Hey everyone, it's an honor again here to be here with Bruce Davie. One of the questions that I'm getting a lot from customers about NSX is they get the use cases within a single data center, but there are a lot of questions on how can we use this across data centers, geo data centers or metropolitan data centers. And Bruce, you have a lot of knowledge on MPLS, obviously, with your background at Cisco. Is there something that you're working on within NSX on solving these use cases?
Yeah, absolutely. There's quite a few things we're doing in the sort of multi-data center space. I'm going to start by sort of sketching out the landscape by drawing a picture.
Okay.
So we can think about there being sort of a spectrum of possibilities, sort of ranging from what I'll call a federated use case, which would be where we have a single data center, but we want to operate multiple separate fault domains within that data center. So potentially multiple coupled NSX clusters, providing separate fault domains, but there's still the ability to build virtual networks that stretch across those multiple clusters. So that's kind of a multi-NSX deployment within a data center. And at this end of the spectrum, you're going to have very low latency because everything's quite close, and you're also going to have quite high bandwidth connectivity between the clusters. The other end of the spectrum is the sort of the geo-distributed use case. And so here you might be separated by an entire continent or by an ocean. And so here you're talking sort of hundreds of milliseconds of latency and fairly constrained bandwidth.
Yep.
And so at this end of the spectrum, you can really think about sort of keeping almost all the functionality that you would have for a single deployment, just being able to bring up multiple NSX clusters and have all the functionality you expect from a single cluster, but just sort of stretch it across multiple deployments. And you could even probably extend that down the spectrum a little bit towards metro deployments. So as long as you're sort of fairly close together, keep the latency in the sort of 1 to 2 millisecond, 3 millisecond range, and keep the bandwidth fairly high, then some of the ideas that will work in a single data center will also work in the metro. And we had a whole session about this earlier in the week, talking about using metro stretched clusters to provide multi-data center solutions with NSX today.
Good, so people who have been here should look up the presentation online. If you have access to VMworld.com, look it up there. Do you have the title for that session?
I recall it had multi-site in the title, but I don't know.
Okay, NSX multi-site, and they'll find it perfectly.
Exactly.
And the reason for federated is probably because people want to sort of separate the fault domains and limit the impact of a fault in case it happens.
For our very large customers, rather than having one NSX controller that's responsible for all the virtual networking state across, say, 20,000 hypervisors, they'd probably rather have 4 NSX controller clusters, each handling 5,000 hypervisors. But it's typically only for the largest customers that we would need that. But the interesting thing about that is that sort of that technology fairly directly translates to what you can do in a metro environment.
Great.
So at this end of the spectrum, we start thinking about exchanging a little bit less information from one site to another. So whereas here we might exchange all the information about policy and firewall state and so on, here we would typically only exchange information about reachability. So here you're going to want to run a routing protocol between the data centers so that as I bring up a virtual network in one data center, I want it to be automatically visible to another virtual network for the same tenant in a different data center. So what I can show you now is how we're tackling this using MPLS as a way of providing multi-tenancy across the backbone and tying the use of MPLS in the backbone to the use of NSX at the edges.
Great.
So a new picture. So we've been working on this for a while, and the basic idea is that you have your NSX controller cluster, and it's controlling a few hypervisors, and you have an NSX edge, and the edge is the way that we get traffic in and out of the virtual network that's controlled by NSX. So today the edge typically connects up to a WAN router, and we can advertise prefixes out to the WAN, but what we don't have in the product today, but what we're working on, is the ability to tie that into MPLS as a way to provide multi-tenant support as you leave the environment managed by NSX and go into a WAN where MPLS is providing multi-tenancy. And so
then you'll hook into the MPLS tagging and everything that happens.
Exactly. So let's say that as we've got, say, an MPLS backbone sitting here and another So this is data center 1, and we've got data center 2 down here, and we've got the same sort of picture down here with another edge, and another NSX controller, etc. So we want to be able to bring up a virtual network here and have it be immediately visible to the correct tenant down in this data center. So what we do is, as we bring up virtual networks here, we're going to connect the edge to the MPLS network using an MPLS labeled interface. So this is what's called an inter-autonomous system interface. Effectively, this is one autonomous system, this is another, and this is a third. Yep. So we're treating this as an autonomous system border, and we run BGP in the control plane between this edge and whatever is sitting on the edge here, the provider edge router, and then this is an MPLS labeled interface. The technical definition of what we're doing here is option B, as it's known in the MPLS world. What that means is you can advertise private addresses from the NSX virtualized domain, and you can attach a route target to those private addresses and also a route distinguisher to ensure they stay unique, even if they might be getting advertised along with other potentially overlapping addresses. So the BGP exchange here is a little bit complex, but it involves route distinguishers for address uniqueness and route target to tag the traffic that belongs to a particular tenant. Right. And then the MPLS label, as the packet comes across here, will distinguish the traffic from tenant A versus the traffic from tenant B. That isolation of tenants is carried across the MPLS backbone and then continues on to this edge with the same exchange. And so now we're able to, so as soon as you create a new virtual network for tenant A, providing you tag it with the correct route target over here, it'll be immediately visible to that same tenant over here, and vice versa. The other so that we originally developed this thinking that service providers would connect this into their own MPLS backbone. But one thing we're seeing is that even enterprises can take advantage of this. Some enterprises run their own MPLS backbone, but even if you just have a traditional IP backbone, you can just build a tunnel from here to here and effectively run the BGP exchange directly between these two devices. So you can get this ability to extend your virtual networks for multiple different tenants across the wide area, and it really doesn't matter if this is 100 millisecond latency or 1 millisecond latency, it'll just work.
It's very flexible, just whatever type of situation a customer has, we can use this to fix it. One other question that I get a lot from multiple data centers is, do we connect up to more than one virtual center? Is that necessary? How do we sort of get around that issue?
That's a good question. So in this environment, you could certainly very easily run one vCenter here and one vCenter here. Obviously, there are some limitations to what you can and can't do if they're different vCenters, but you will certainly have no problem being able to create virtual topologies over here, advertising them out here, and having them automatically connected into your virtual topologies here, so you have no issue with having to stretch your vCenter across the universe.
Right. Oh, well, that sounds really good. Obviously, this is something that we're working on. I won't put you on the spot and ask you when it's going to be available, but if people want to be updated and kept in the loop on sort of your developments, what could they do? Could they go to a blog, to the website?
Absolutely. So I blog in a few different places. I'm often on Network Heresy, which was created by Martin Casado, and I also have a personal site on the CTO website for VMware, so cto.vmware.com. I do a bit of blogging there, so yeah, that'd be two good places to look. And of course, you can follow me on Twitter.
Perfect. What's your Twitter handle?
So it's _ Dr. Bruce D.
Perfect. I think anyone should be able to find that. So either go to the blogs, follow him there, or follow him on Twitter, and make sure you're one of the first to benefit from this new MPLS integration with NSX whenever it's available. Thank you very much, Bruce.
All right, it's been a pleasure. Thank you.